Hello students, how are you? Today we discuss about the indefinite integral part 1. In part 1, we just took one method of solve the indefinite integral questions. What is indefinite integral? Indefinite integral is antiderivative, is also called indefinite integral. Antiderivative are called indefinite integral. Question arise, what is this antiderivative? Antiderivative is the reversible process of derivative, and this derivative is related with the differentiation. What is differentiation? Differentiation is centered at the concept of your derivative. If any function f is differentiable in the interval I, then the derivatives also lies in that particular interval at each and every point. Number of methods to solve the problems of indefinite integral by converting into proper formula or standard results. So, number of methods to solve for solving integral problems by reducing them in the standard form. Prominent among them are the methods based on number 1. First we are taking integration by substitution method. The second one is integration using partial fraction. And third one is integration by parts. Here in this part 1, we discuss about the integration by substitution method, and another part we take, that is integration using partial fraction, and in the third part we are taking integration by parts, and if necessary fourth part we are taking some other methods of integration related with the other standard forms. Now first of all we are taking, we will consider in this part, that is integration by substitution. Integration by substitution. In this integration by substitution, we are first of all take the example, that example 1. Example 1 is your integrate 2x upon 1 plus x square with respect to x. solve this type of problem. Integration by parts, that we take the first example. Integrate 2x upon 1 plus x square with respect to x. With respect to x means, here how can we solve this one? First of all, we have to take in let I is equal to, because every integrating problem we start, always we write a capital I. This capital I is equal to, this is the sign of integration, and this is written as 2x upon 1 plus x square dx. And when it is 2x upon 1 plus x square dx, I just suppose that 1 plus x square is equal to t. We try to take substitution in such a way that the numerator value is same, or we can use a proper formula for the integration. Here, suppose 1 plus x square is equal to t. When I have taken 1 plus x square is equal to t, I have just taken 1 plus x square, and this is equal to t, multiplying both sides by d. And in the second step, d by dx, 1 plus x square dx is equal to dt. This method only I am just this time I introduced, because this is first time I am explaining this one. So this is the way we can write directly here also, and this is can be written as d by dx into 1 plus d by dx into x square, and dx is equal to dt. By the simple differentiation, that this is equal to 0 and that is equal to 2x, dx is equal to dt. Now in this question, this is equal to this 2x dx is equal to dt, and this is numerator value, and this is equal to I is equal to 2x upon 1 plus x square from equation 1. So this is equation 1, and this is 2x upon 1 plus x square dx is equal to dt upon t. And I know that the integration of dx upon x is equal to log of mod x. It is strictly a positive quantity, and that is why it is equal to log of t plus c. What is t? T is equal to, as we suppose, 1 plus x square, so that is equal to log 1 plus x square plus c. This is the solution of the first question, or we can say that's our answer. This c is integrating constant. Here remember students that this c we are going to use, it is initial stages when we start the study of the integration. We show that our integration process is complete, it's over. At that time we use this particular integrating constant. But after that we just avoid this one. And this c is also only introduced in the indefinite integral, not definite integral, because definite integral having some standard values, some fixed values. Now we have again we take the another example, that integrate any substitution method. We have to take that e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x with respect to x. Here we are using the exponential function. Let I is equal to, as I already told you, that e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x dx. Here the substitution method is suppose that e to the power x plus e to the power minus x is equal to t. I suppose this the denominator is t, and we will write here that e to the power x plus e to the power minus x dx is equal to dt. When we differentiate, this is d by dx e to the power x plus d by dx e to the power minus x dx is equal to dt. The standard form of differentiation e to the power x is e to the power x. But this d by dx e to the power minus x, we have to solve this e to the power minus x for the differentiation in such a way that we use the standard form. Okay, how can we use this one? Suppose I am taking d by dx e to the power minus x. I am using here the differential calculus or differentiation formula chain rule. This chain rule is equal to, this chain rule is df upon dx is equal to df upon dt into dt by dx. But minus x is equal to t. When I take this minus x is equal to t, here in place I will write here d upon dt e to the power t, and d upon dx is minus x, and therefore this is e to the power t minus 1, and that is minus e to the power minus x is d by dx e to the power minus x. So what's our this complete differentiation like this, that e to the power x minus e to the power minus x dx is equal to dt, and this is what? This is our numerator, and this is written as minus dt upon t, and this is equal to log of t, because we already know that integration of dx upon dx is equal dx upon x is equal to log mod x, and this is equal to log, what is x? X is equal to e to the power x plus e to the power minus x plus c, where c is integrating constant. These are the two questions. You can understand which type of this substitution methods into various type of questions. Now in the second part, we discuss about the second method, integration using partial fraction. This partial fraction is a special type of method which are generally in the denominator such algebraic or trigonometric functions arise that we are not solved in our old method. Therefore, we use this special method, that's your partial fraction. Now we discuss in the second part. Okay, goodbye all of you.